Hello viewers, welcome to my channel and thank you for watching the videos and subscribing the channel. इस वीडियो में हम जैकोबीज मेथड कंटिन्यू करेंगे. पार्शियल डिफरेंशियल इक्वेशन का टॉपिक है. वर्किंग रूल, इसका प्रोसीजर एंड हाउ टू गेट ऑक्सिलरी इक्वेशंस ऑफ जैकोबीज मेथड वो हम प्रीवियस लेक्चर में कर चुके हैं, प्रीवियस वीडियो में. दिस मेथड इज फॉर सॉल्विंग पार्शियल डिफरेंशियल इक्वेशन विद 3 और मोर इंडिपेंडेंट वेरिएबल्स. तो स्टेप 1 है, ये हम मान कर चलते हैं जो गिवन इक्वेशन है उसमें 3 इंडिपेंडेंट वेरिएबल्स हैं. सपोज द गिवन इक्वेशन विद 3 इंडिपेंडेंट वेरिएबल्स is, we can write in this form: f of x1, x2, x3, p1, p2, p3 is equal to 0. Mark it equation 1. Step 2, we write Jacobi's auxiliary equations. And these equations are dp1 upon del f upon del x1 is equal to dx1 upon minus del f upon del p1 is equal to dp2 upon del f upon del x2 is equal to dx2 upon del f upon del p2 with the minus sign is equal to dp3 upon del f upon del x3 is equal to dx3 upon minus fp3. So fp3 means partial differentiation with respect to p3 with minus sign. Now solving these equations we obtain 2 additional equations and we try to find those equations that after getting these 2 equations we have to solve these 2 equations with equation 1 so that these equations are easy to solve. So we select those equations. So suppose these equations are f1, x1, x2, x3, p1, p2, p3 is equal to a1 and f2, x1, x2, x3, p1, p2, p3 is equal to a2. These 2 equations where a1 and a2 are arbitrary constants. So as I said, we will try to find out simple equations so we can solve 1, 2, 3 easily. On step 3, we will check and verify that the relations 2 and 3 satisfy the following conditions. These conditions are f1, f2 is equal to sigma r is equal to 1, 2, 3 del f1 upon del xr del f2 upon del pr minus del f1 upon del pr into del f2 upon del xr is equal to 0. Mark it as 4. If this condition, that is 4, is satisfied, then we solve 1, 2 and 3 equations. So if equation 4 is satisfied, solve equation 1, 2 and 3 for p1, p2, p3 in terms of x1, x2, x3 and then we substitute in dz. dz is equal to p1 dx1 plus p2 dx2 plus p3 dx3 and then integrate and this leads to, or this gives a complete integral of the given equation. Integration will give the result, required result, that is value of z. Now अल्टरेशन क्या हो सकता है? नोट 1, कभी कभी हमें चेंज ऑफ वेरिएबल्स यूज करनी पड़ सकती है. एंड सेकंड नोट है, जब हम पार्शियल डिफरेंशियल इक्वेशन सॉल्व कर रहे हैं 4 इंडिपेंडेंट वेरिएबल्स के लिए, ये वर्किंग रूल 3 इंडिपेंडेंट वेरिएबल्स के लिए लिखा गया है. सेम हम उसे मॉडिफाई कर सकते हैं 4 के लिए. मॉडिफाई इट टू द रूल फॉर 4 इंडिपेंडेंट वेरिएबल्स. जो 3 वाला है दैट वी विल मॉडिफाई और हम इसी के पैरेलल लिख लेंगे. उस केस में स्टेप 1 हो जाएगा f x1, x2, x3, x4 P1 P2 P3 P4 इज इक्वल टू 0। ऑक्सिलरी इक्वेशंस हो जाएंगी जैकोबीज ऑक्सिलरी इक्वेशंस dP1 अपॉन डेल एफ अपॉन डेल x1 इज इक्वल टू dx1 अपॉन माइनस डेल एफ अपॉन डेल P1, और ये चलेगा लास्ट होगा dP4 अपॉन डेल एफ अपॉन डेल x4 इज इक्वल टू dx4 अपॉन माइनस डेल एफ अपॉन डेल P4। सो रिमेनिंग जैसे हमने की थी ये इन बिटवीन आएंगी x2 एंड x3 के रिस्पेक्ट में भी। नाउ वी सॉल्व करेंगे और यहाँ पर हमें इंस्टेड ऑफ 2 वी विल गेट 3 एडिशनल इक्वेशंस, और वैसे ही होंगी जो कि f1 एंड देन दिस x1 x2 x3 x4 p1 p2 p3 p4 is equal to a1, or similarly we will have f2 with all these variables is equal to a2 and f3 with all these variables is equal to a3। so these equations हो गई 2 3 and 4। अब इन्हें हम सॉल्व करेंगे along with the equation 1 a1 a2 a3 these are arbitrary constants। वेरीफाई क्या करेंगे कंडीशन, द कंडीशंस f1 f2 is equal to sigma r is equal to 1 to 4 del f1 upon del xr into del f2 upon del pr minus del f1 upon del pr into del f2 upon del xr is equal to 0। इसी तरह हम लिख सकते हैं f2 f3 सेम लाइंस पर, एंड वी कैन राइट डाउन f3 f1। इस केस में f1 रिप्लेस हो जाएगा 2 से और 2 रिप्लेस हो जाएगा 3 से। हेयर वी विल रिप्लेस 1 by 3 एंड 2 by 1। सो रिप्लेस करके हम कंडीशंस लिख सकते हैं। सो दिस वी मार्क एज 4 and this will be 5th and 6th। these 3 conditions 4 5 6 satisfy हो जाती हैं। if satisfied then what we do, we solve the equations 1 2 3 and 4। solve the equations 1 2 3 and 4 for P1 P2 P3 and P4 in terms of x1 x2 x3 and x4। और उसके बाद हमें क्या लिखना है, dz is equal to p1 dx1 plus p2 dx2 plus p3 dx3 प्लस P4 dx4 एंड इंटीग्रेट करना है और हमें आंसर मिल जाएगा z की वैल्यू। सो अब पास्ट ईयर पेपर्स पर बेस्ड एग्जांपल्स करते हैं। ये एग्जांपल 1997 का है। फाइंड ए कंप्लीट इंटीग्रल ऑफ p1 क्यूब प्लस p2 स्क्वायर प्लस p3 इज इक्वल टू 1। तो स्टेप 1 है कि हमें फंक्शन राइट करना है। सो दिस इज f x1 x2 x3 p1 p2 p3 is equal to p1 cube plus p2 square plus p3 minus 1 is equal to 0। now we write Jacobi's auxiliary equations। so this is dp1 upon del f upon del x1 is equal to dx1 upon minus del f upon del p1 is equal to dp2 upon del f upon del x2 is equal to dx2 upon minus del f upon del p2 is equal to dp3 upon del f upon del x3 is equal to dx3 upon minus del f upon del p3। सो वैल्यू सब्सटीट्यूट करते हैं, dp1 अपॉन x1 नहीं है, सो दिस इज 0, p1 के रिस्पेक्ट में 3p1 स्क्वायर, बाकी टर्म्स को हम कांस्टेंट की तरह ट्रीट करेंगे। सो dx1 बिकॉज ये पार्शियल है, 3p1 स्क्वायर विद माइनस साइन इज इक्वल टू dp2 अपॉन 0 इज इक्वल टू dx2 अपॉन माइनस 2p2 is equal to dp3 upon 0 is equal to dx3 upon minus 1. So from here we get dp1 is 0, dp2 is 0 and dp3 is 0. So these they give integrating, p1 is equal to a1, p2 is a2 and p3 is a3, where a1, a2, a3 are arbitrary constants. And here p1 is what? p1 is f1, x1, x2, x3, p1, p2, p3 is equal to p1 is equal to a1, and f2, x1, x2, x3, p1, p2, p3, where f1, x1, x2, x3, p1, p2, p3 is equal to, we call it p1 and this is a1. So p1 is equal to this, f2 is, which is function of x1, x2, x3, p1, p3, this is basically p2 and which is equal to a2. So now we check the conditions, verify the conditions whether they are satisfied or not. So here it will be f1, f2, and f1, f2 is sigma r is equal to 1 to 3 del f1 upon del xr, del f2 upon del pr minus del f1 upon del pr and del f2 upon del xr. So we expand it, expansion gives del f1 upon del x1 del f2 upon del p1 minus del f1 upon del p1 into del f2 upon del x2 x1 plus del f1 upon del x2 del f2 upon del p2 minus del f1 upon del p2 del f2 upon del x2 plus del f1 upon del x3 del f2 upon del p3 minus del f1 upon del p3 and del f2 upon del x3. So this is the value. Now we put values in this, and f1, this is the equation basically which we have to differentiate. So f1 with respect to x1 is 0, f2 with respect to p1 is 0 minus f1 with respect to p1 is 1, and then 0, f2 with respect to x1 is 0 plus f1 with respect to x2 is 0, f2 with respect to p2 is 1 minus f1 with respect to p2 is 0, f2 with respect to this is also 0, then f1 with respect to x3 is 0, f2 with respect to p3 is 0, and then also this also will come 0. So we see the resultant is 0. So we see the expressions, this is equation 1, this is equation 2 and 3, 2 and 3, and this is 4. So we say equation 4 is satisfied by using equations 2 and 3. It means condition is satisfied, so we can solve equation 1 with the two additional equations 2 and 3. Equation 4 is satisfied by the equations 2 and 3. So we can solve equations 1, 2 and 3 for P1, P2, P3 in terms of x1, x2, x3, whatever is given. So P1 is equal to A1, P2 is A2 and P3 is 1. From the question we can get this minus A1 cube minus A2 square. We put these values in dz. dz is equal to P1 dx1 plus P2 dx2 plus P3 dx3, which is equal to A1 dx1 plus A2 dx2 plus 1 minus A1 cube minus A2 square dx3. Integrate it. Integrating z is equal to A1 x1 plus A2 x2 plus 1 minus A1 cube minus A2 square x3 plus some constant A3, integrating constant. This is the complete integration of the given equation where A1, A2 and A3 are arbitrary constants. Next example is of 1998. Find the complete integral of 2p1 x1 x3 plus 3p2 x3 square plus p2 square p3 is equal to 0. So this is equal to x1 x2 x3 p1 p2 p3, which is equal to 0. So we write Jacobi's auxiliary equations, that is dp1 upon del f upon del x1 is equal to dx1 upon minus del f upon del p1 is equal to dp2 dx dp3 dx3 del f upon del x2 minus del f upon del p2 del f upon del x3 minus del f upon del p3. So we put values in this, or dp1 upon 2p1 x, we are differentiating with respect to x1. So from here 2p1 x3 and there is no x1 is equal to dx1 with respect to p1. So 2x1 x3 minus is equal to dp2 x2, no term of x2, so 0 is equal to dx2 upon with respect to p2 from here and here 3x3 square plus 2p2 p3 is equal to dp3 upon 2x1 p1 plus 6p2 x3 and dx3 upon minus del f upon del p3. So which is coming from here minus p2 square. So we got this by auxiliary equations. Now we find out two fractions and integrate them to get the two relations or two equations. So we take first two fractions and see x3 cancels out, 2 cancels out. So log p1 is equal to minus log x1. So x1 p1 is equal to constant, say a1. And if we take third fraction, this, it gives p2 is equal to a2. a2 is arbitrary constant. So these two relations we got, and from here we can write f1 f2, and then we will check, verify that f1 comma f2 is equal to 0 is satisfied or not. So f1, x1, x2, x3, p1, p2, p3 is equal to p1, x1 is equal to a1, and f2 is same variables, which is p2 is equal to a2, expression 3, relation 3. So now we have, this is equation 3. So now we verify f1, f2 is equal to 0, satisfied or not. So this gives, so we write f1, f2, which is equal to so we put values in this expression. We have px1 is equal to a1, p1 x1 is equal to a1, and p2 is equal to a2. So this is f1 and this is f2. Put the values with respect to x1. We can write, from f1 we get p1 x1 minus a1 is equal to 0, and from f2 we get p2 minus a2 is equal to 0. So we use these equations and put the values in this. So del f1 upon del x1 is p1, del f2 and with respect to p1 is 0, minus f1 with respect to p1 x1 to with respect to x1 plus f1 with respect to x2 1 minus f1 with respect to p2, f2 with respect plus f1 with x3 and 0. So this is 0, so verified. It means solve equations 1, 2 and 3. So what we get, p1 is a1 upon x1, p2 is a2, and p3 is minus 2 a1 x3 plus 3 a2 3 square upon a2 square. So we got the values of p1, p2, p3. We put in dz. dz is p1 dx1 plus p2 dx2 plus p3 dx3, and then integrate. So this comes integrating z is equal to a log x1 plus a2 x2, and here with respect to x3. So this comes x3 square upon 2, x3 cube upon 3. got the complete integral in the form of z, and that is the answer. नेक्स्ट एग्जाम्पल है 1995 का. कंप्लीट इंटीग्रल फाइंड आउट करना है. P1 P2 P3 इज इक्वल टू z क्यूब x1 x2 x3. सो हम इसे लिख सकते हैं del z अपॉन del x1 del z अपॉन del x2 del z अपॉन del x3 इज इक्वल टू z क्यूब x1 x2 x3. सो डिपेंडेंट वेरिएबल z है, एंड जो इक्वेशन 1 दी गई है स्टैंडर्ड फॉर्म में नहीं है. पहले हमें स्टैंडर्ड फॉर्म में रिड्यूस करना होगा. सो वी राइट 1 अपॉन z del z अपॉन del x1, 1 upon z del z upon del x2, 1 upon z del z upon del x3 is equal to x1 x2 x3. So 1 upon z dz को हम लिख लेते हैं d capital Z. It means log small z is equal to capital Z. So अब हम इसे लिख सकते हैं del of capital Z upon del x1, del of capital Z upon del x2, del of capital Z upon del x3 is equal to x1 x2 x3. ये हो गए P1 capital P1 P2 P3 is equal to x1 x2 x3. अब हम यहाँ से लिख सकते हैं f of x1 x2 x3 P1 P2 P3, these are capital, is equal to P1 P2 P3 minus x1 x2 x3 is equal to 0. So this is equation 1. Now we write Jacobi's auxiliary equations, and we get dp1 upon del f upon del x1 is equal to dx1 upon minus del f upon del p1 is equal to dp2 upon del f upon del x2 is equal to dx2 upon minus del f upon del p2 is equal to dp3 upon del f upon del x3 is equal to dx3 upon minus del f upon del p3. We put the values in this with the help of the given equation which we have reduced in the standard form. dp1 with respect to x1 is minus x2 x3 is equal to dx1 with respect to p1 p2 p3 with minus sign is equal to dp2 upon with respect to x2 minus x1 x3 is equal to dx2 upon del p2, that is minus p1 p3 is equal to dp3 upon minus x1 x2 is equal to dx3 upon minus p1 p2. So we can write from this equation, we can write in this x2 x3 as p1 p2 p3 upon x1, and we have this dx2 also. So we take these two terms and solve it. It gives, we take this term and this term and solve the expression. So dp1 upon x2 x3 is this is equal to dx1 upon p2 p3. So here this is p1 p2 p3 with minus sign upon x1, and here it is p2 p3 with minus sign. So p2 p3 will cancel out and this will go here x1. So we get minus minus will cancel out. So dp1 upon p1 is equal to dx1 upon x1. So we can integrate it. So integrating we get log p1 is equal to log x1 plus constant log a1 which is equal to P1 is equal to A1 x1. So we got F1 x1 x2 x3 P1 P2 P3 is equal to P1 minus A1 x1 is equal to 0. And similarly we can have from the terms when we take dx2 upon P1 P3 is equal to dp2 upon minus x1 x3. When we do solve it, we will get f2 x1 x2 x3 P1 P2 P3. We will have, because this will give log P2 is equal to log x2 plus log A2. So P2 minus A2 x2 is equal to 0. Because here we have put x1 x2 x3. This is equal to minus x1 x2 x3. So we cancel out x1 x3 and x2 is there upon P2. So this will give log P2 is equal to log x2 plus log A2. So these two now we got. As we did in earlier questions, we can show f1 f2 is equal to 0. So we can verify that f1 f2 is equal to 0 as we did in earlier questions. It's satisfied. It means now we can solve the equations, and solving the equations, the given equation which you can mark, then A and B, these we solve. So P1 is equal to A1 x1, P2 is equal to A2 x2, and now we have to write P3, which comes. Now this we obtained by the given equation, and in the question was P1 P2 P3 equal to z cube x1 x2 x3. So we are not using it directly. What we had done, we had transformed it into P1 P2 P3 is equal to, this is capital, these are small, and in the question, and these are capital x1 x2 x3. So we take this which we had transformed. From here we can write P3 is equal to x1 x2 x3 upon, all these are capital P, P1 P2. Now we put it into dz. Dz is also capital P1 dx1 plus dx2 P2 dx2 plus P3 dx3. We put the values of P1 P2 P3 and then integrate it. So this is A1 x1 dx1 plus A2 x2 dx2 plus x1 x2 x3 upon P1 P2 then dx3. Now we put values of P1 P2 from here, then this becomes A1 x1 dx1 plus A2 x2 dx2 plus x1 x2 x3 upon A1 x1 and A2 x2 and dx3. So x1 x2 are gone, x3 upon A1 A2 dx3. This is equal to dz. Now integrate, and this gives 1 by 2 A1 x1 square plus 1 by 2 A2 x2 square plus this is equal to capital Z 1 by 2 A1 A2 and x3 square plus constant. We say constant is A3, and because everything is by 2, so we take it by 2. So we cross multiply 2z is equal to A1 x1 square plus A2 x2 square plus 1 by a1 a2 x3 square plus a3, and we put the value of z which we had taken log small z, and the same thing right hand side is same, this term, whole term. So this is the required answer.